Okay, so hi everyone, hi people online. Today we have Patricia Fort. So Patricia is the mastermind behind the Python meeting this year. She's also a senior master student here at PUC. She did her bachelor's as well. And today she'll be presenting photometric analysis for Redshift Estimation.
Thank you, Ellie. Thank you everyone for coming. Today I'm going to talk about LePHARE, that is a code for redshift estimation. So I don't have a reason why LePHARE. It honestly just like fell into my lap, and I have been using it ever since. There's a lot of other codes, but if you only want to estimate redshifts, I think this is a very good code. And what it is particularly, we have an SED distribution, so a spectral energy distribution, and we will have our sample photometric fluxes or magnitudes. And basically what the first does is a template fitting code. So it will take an SED and it will try to match based on chi-square distribution what is like the best SED in the catalog that will match our magnitude or fluxes. So it's very easy to use. And the installation is actually very simple. If you ever have doubts about this, we have other Python meetings for installations of code and stuff like this, but this is very simple. It's just we install LePHARE. It probably will overwrite some libraries. But right now they're working on this. Like this is very new to the code. When I started using it, wasn't that easy, but now it's very nice. And also, actually, if you want to do this, but you don't have the time, maybe you don't want to install LePHARE and maybe it's kind of complicated for you in this moment, you can also go to the website that the Laboratorio Marseille have. They and I think other code where they like condense everything in this website, and you can upload everything you want to do, and they will do it for you. It's not fast because there's a lot of requests, but if you have the time to wait for a result, this is like the easiest way to go to LePHARE. And it was my first first time meeting. That's very useful. So what does LePHARE does is that will be stored in have the filters that you're going to use. And finally, you will have the magnitudes or the fluxes for your objects. And when you take all of this as a recipe, it will also compute the redshift. So if you want to do more, of course, we already had a Python meeting by Victoria, where she showed a Sigal, where you can obtain a lot of other parameters. But LePHARE, I think the most important thing you have to take from this is that it's very fast for a bunch of objects. Like if you have a survey where you have 10,000 galaxies, it will run in 5 minutes. So it's super fast just to compute the. I haven't done other things with it, but I know there is like some SUV that only for zphot you have to run this part, but it's going to be very easy to understand when we check the code. Another thing is that LePHARE has a lot of filters from a lot of instruments and telescopes, and they're all located when you install the program in the folder title field. There you can find like this type of files where you will have the wavelength and the transmission normalized, but you can also add more. You only have to create another folder in the filter folder, and then you will have more SEDs, sorry, more filters that you can use. And also there's a lot of SEDs. What I like about LePHARE is that you galaxy, quasars, or stars, and you can do the 3 different of the redshift. You also actually a quasar on their chi-square that you will fit. So very useful. And also here, I have never add more, but there you can add more. And if not, you can go to the website, and in the website, they have every single SCP. And if you want to, for example, since I use always galaxies, here like lower panel that I actually add the page, the documentation updated, so it's very good. And I noticed that now you can run LePHARE in Python. So you can add a Jupyter, and the Jupyter you can add import LePHARE, and you can like do everything in the Python. But I think the easier way to like remember what you were doing is to have a parameter file. So you can create this params.para, and you can store all the keywords that you will use. Here I put like an example from the GitHub from LePHARE, because they have like a very distinct like configuration, right? Because it's very simple. And also I put here the different keywords. Of course, everything will be in the website, so you can then check it. But there's a lot of keywords. Like it's very easy to change everything, but some of them are mandatory, but some of them really don't matter and use the default. But if you don't put one that is very mandatory, it will not run, so you don't have to worry about that. What else? Oh yeah, there is one already in the working directory that is an output parameter that then you can put all of the outputs that you want, because you can return the best redshift, you can return all the distribution, or also you can return the chi-square. And if you want even more, you can even return like the absolute magnitudes based on that redshift, and a lot of other things that it returns by default. But you can like comment those if you don't want. And the most important thing here is that you only have to give LePHARE a catalog. Access, I think are in Earth second, I don't know, but you can check it in the website. But I think the easiest is magnitudes, apparent magnitudes, and you can do a magnitude error for each band, or all the magnitudes and then all the errors, but you have to say to LePHARE which one are you using. And something that also is in the website is that you can have a very short catalog that is only going to be the magnitude. That I think is very, very good is that if you have, for example, I have 11 bands, and in one of my galaxies, I don't have G band. And LePHARE is not going to know that by default. So probably it's going to use a very vast photometry in that. What you can do is give it a context. Everything is great. You just go and for each galaxy give and then you. And all the rest is extras. I don't know why, because you don't use it, but you can put other and etc. So now it's of course the fun part. I'm going to show you what I've been doing for LePHARE. So sorry, that's my work. So first thing, you're going to have a catalog. So the catalog is going to look like this. You can keep the ID, it's not going to use it, but you can give the ID, and then the magnitudes and the errors. That's the one I'm using. The names, this is different to Sigale. You don't have to give it a name. Like it's all going to count when you give the filters that I'm going to show. But you can put like any name and it will work the same. And then you also will have this part that I was telling you. This is the cosmos.para that they have in the website. And then I went and sorry, my data set. So sadly, I'm not going to be able to show you stellars and quasars, because when I'm working in a server and my professor, when he did the installation of LePHARE, I don't know what he did, but there is no but we have galaxies. That's the most important thing. So you can give the different libraries. So at the beginning you have this. And for example, I'm using here the Cosmos modification list. That is the ones that they have installed in LePHARE. But you can go and check the others. I think this works best for my science, but there's a lot of other things you can use for passive galaxies, Arctic galaxies, whatever, Star Wars galaxies. And this is the part where you have to keep the filters in the correct order. So you have to go and give all the different paths, but they have to be in the same order that the catalog. So if you have the U-band, then you have to give first the filter list, the U-band, of course. And then you use everything in one parameter. And then you have all these different part of configurations that you can check in the filter if they're energy or their photons or whatever you put it here. And then you say like, I will be using all of these SEVs for running. And here you say if you're using Vega or AB magnitudes, the step of redshift that you want to use. I don't know what is the limit, like if you can go even lower than this grid, but I haven't tried it. And this everything here is exactly as the web page put it. I just keep it like that. And then you have this configuration that is very useful for my job, for example, is that these templates don't have emission lines. So if you want to look for galaxies that are emitters, you have to add to the templates emission lines if they don't have it. So you can say, okay, you can have no emission lines or add emission lines based on different configurations. And you have to change this catalog part where you put your catalog, say if it's magnitude or it's fluxes, AB magnitude or Vega, the configurations that I told you, like magnitude error or magnitude error. And also here is this part that what I was telling you about, that you have a context. I recommend that you give the context. Don't translate with the context because it will use all the bands. Or I don't know, like it's not very strict with each one of the galaxies. And then for this is the part where you say like, this is my galaxy template that I'm going to use. And you can say which templates you want to add the emission lines. So maybe you have a passive galaxy that you don't want to add emission line, but so you take it out. And then you say where you want to store it, different catalog outputs. And here is the part that I told you that you have these parameters that are out, that are the names of the variables that you want to save. And in this case, I'm just using the one that it comes with LePHARE that returns everything. But if you only want the redshift, you can use just copy that one to your working directory and just comment everything that you don't want to use. And finally, there's a lot of other things that I'm not using because you have far infrared libraries right now and different priors that you can change and adjust. For example, the only one that I think I'm using, not in this case, but in my work, is that you can say which one is the I-band. If you have I-band, you can say to LePHARE, like my third filter is my I-band, so it will use it as a prior for all the measurements. So it's know that that one is the I-band. And there's a lot of other things that are probability that I'm not really an expert on, but you can check this out. And the last thing I want to say is that you can recover the spectrums, the SED with the best fit that you have, but this will take a lot of space. So if you have, like me, like 10,000 galaxies, don't make a video with 10,000 galaxies, just do it this to check like 10, 20 galaxies, it will take a long time. And the rest, I don't know. The rest is just how it came. And what I do that I think is simpler, because usually what you have to do right now in the way that they teach how to use LePHARE is that you go and make a Jupyter with all of these configurations and you do everything. But the easiest form is that once you have the very, very good balance.para, you can make a script where you import the directory and your work directory. And then you just run the different properties. So as I said before, you have the SED to live, where you will store the SEDs that you were going to use. And here you only give like the name of the Python script. Then you give your parameters that you're going to use. And you have to specify if this is a galaxy, a quasar, or a star. So here I have the quasar and a star, but it's not going to run because I don't have those templates. Then you have the filters that you have to say, okay, we are using that are in my params. Here you don't have to say anything else. And then for the last part, you have to give the magnitudes. And here again, you have to say, use a galaxy, a quasar, or with G, Q1, or S. And finally, you have to make the photometric redshifts. So you run this one. I think now with Python, you don't have to give the whole like path. You only use this one. I don't have that. Sorry. So you give it this, and then if you want to save the spec, here I'm sure it's probably somewhere, but they have like a very like manual script that is called spec.py. You have to have it in your working directory, and then it will create the different configurations. So I'm going to very like quickly run it so you can see like what it does. But you still do batch the script, and it will run the script like that. So I'm going to make it larger. So right now it's going to do like all the different SEDs. So it's going to look for all the SEDs to on the extinction log in the of the redshift is going to take longer. You only want like a very smaller grid, but in this case I did a very small one, so it's going to take a while. But this is like time. But after that, it's very fast. So save this, and once we have the result, is going to be saved also in the catalog out, because maybe you forgot if you put emission lines, or if you use a step that was larger, or maybe you don't know which parameter you use. So everything that is here is going to be catalog out. So that's very good if you have very bad memory. Or if you also you have like different catalogs, it also says when you create it. So that's very good, because sometimes you don't know like when you did it. Okay, so now here's going to the CD. It was very fast because I only have. But what I wanted to show you is that here you can check if your filters are good. So here you have all the filters up to use. You have to run it once, check, and then go back. Because if you upload one of the filters that is not normalized, I think it's going to have some issues. But if not, it's good. So now the last thing I want to show is that it creates this very nice PDF that where you will have the probability distribution of the redshift. It's going to have the best SED for your galaxy, and it's going to show the photometry. And in the upper part, you can see in red that we have the redshift of the galaxy and the chi-square and other values that is not going to produce, because I didn't use a CD that had this information. I only want the redshift. But here you can check like all your different galaxies. Sometimes I think in this case there is none, but sometimes it will give a second solution. Okay, so that's another parameter that you have in. Oh, it didn't find anything for this one. But sometimes there's another like SED. Okay, in this case it didn't do the second. But if there's two templates that fit the data, it's going to give you a C second. So it's going to give you a second solution, because as you can see here, I only find like one redshift that it's going to fit. Or in this case like this, probably has a second distribution that you will find in the catalog, that is this one, the catalog out. And if you go and check it, you can see that it's a Gemini or ChatGPT how to where it was very difficult to learn how to use it. So I'm very glad we had this chance to do it. And I'm going to back to my presentation for the takeaways. So I love it because it's very flexible and it's very robust. Another like sample of a photometric rate. And also the nice that they have now is that you can use it as a script or as a notebook. Also, it's very efficient. It's very, very fast. I think this is really nice when you have large scale surveys because it will take like 10,000. Only one directive. This is amazing. And as you have the video, never use it. Honestly, I maybe should, but it's very good if you're like very, you know how to do this stuff. And also you can derive another parameters from the Redshift SED that I didn't do in this case because I only want to show you how it works, but it's an amazing code and it's very, very, very old. Like when I was doing this, I saw like all the history that it had, and I think they created it in 1999. So it's older
You're
than
calling
me.
that old?
Yeah. Older than me. Yeah, but thank you very much.
I saw that in the context. For example, if you put -1, it took like it ignored the band. Something like that.
Yeah.
Is that always true, or do you have to like write?
Yeah, maybe I can show the page maybe where I have it here. Okay, so the thing is that when you have the context, it will override the context that you gave. So if you use -1, I think it will take all the bands. So the context is going to be all the bands. If you want to, what I said is that I'm going to show you the equation, I think. So here's the documentation. It's like very good. I know. The context. And here. So for example, this one. Sorry. Sorry, my screen again. Okay. So you have like they have this example here. Okay, so they have like you have these filters. So each one is going to be a number. So the first one is 1, the second one is 2. And for example, if you have all of the bands, the context is going to be 100. Sorry. So if you have, for example, you don't have the photometry, and it's going to use it anyway. And it's going to like not feed you anything. So this is like a very good way of like making sure you have like the best out. I think this is like a binary thing. Other question?
I'm trying, yeah, I have like, so this is open source, so anyone can use it.
Yeah.
I was thinking about using it for emission lines in galaxies. So that how easy it is to implement emission lines. Because I think you had.
Yeah, you have the I'm going to share the post. Well, in my case, I'm also like analyzing galaxies with the emission line. So if I have a band that is going to trace the emission, so this one. So for example, if you have this template, it's like this without the emission. So you have to add it, but the addition is like only that line, like add the emission line, yes.
Okay.
It's going to add the emission to the different bands. And then you have the 3 different configurations. That is the like emission in UV, the star formation, something. And you have to read them, but I think one of them is like based on your data. The other one is like something, but I have to find it, but they are different. Density of the image. That's the only thing it's going to change. But it will add them automatically. And if you only want some of them, I think the best way to do it is you make your own like SED like text, and you order them like this is the ones that I want SED, this is the one that I don't want, and then you give the one that line that I showed you that go. It was like where it was. This one, add emission lines. So you say like I want from the first one to the fifth one. The rest is not going to add emission.
Oh, I see.
It's very simple. Okay. It's very, very simple. And you can change everything here to match your data.
Okay, I have another question. So that do you can provide like a limit for how well is the output? So like whether you can try and not again with I don't know another set of parameters or make like a smaller read. Does it have like an active feedback so it knows like rerun things, or do you have to like go back and
I think you have to like check your results and then see like those are the ones that you expected. But then you will have to go back. Maybe you can check the t-square, maybe the fit that is good. I think you can add one thing that I don't have here is that you can like limit the t-square. So if you don't want it to go like very, very high t, you can like give a limit, and if it reaches that limit, it's going to ignore that galaxy and just give you the other one. So then you can check like if the configuration is good. But yeah, it's not like that hard. I think photometric redshifts are like a blind box that you go in and you like I heard like Jorge say this. Like if you ask for red apples, it's going to deliver red apples. But you will know based on like for example the multi-spec, you will know if it's fitting like or not fitting.
Yeah.
So yeah.
Do you have more questions?
I'm sorry if I missed it, but it's a template fitting, but how does it fit? Does it use like
okay, so I didn't want it to go there because
then don't go there. No worries.
But it's like a formula. It just takes like this like t-square thing where you have to observe flux and the one from the template. So that's why it has like this filter and SED where it like bakes the SED based on your data, and then you will have this. But it's only this, like it's so the observing minus the template over and over again. But it's very fast.
Yeah.
So
Okay. If there are no more questions, we're gonna thank you for aquí. Do you have a message for the people online?
yeah. So thank you everyone for coming again. People that are here and people online, and if you're watching in YouTube, thank you for watching. We hopefully will be making this for the next semester, and we have next week our last major meeting for the semester. So thank you for coming. It has been very good. See you next week, and subscribe, like, and comment. Thank you. Last week.